Hey guys, my name is Jason with Mount Baker Mining and Metals, and on today's video, I got a customer coming with a sample of lead silver ore. We're going to crush it up through the hammer mill behind me and onto the shaker table, and then we'll try and smelt some of it down and see if we can recover some of his silver. So it hangs back behind the lid.
Oh, okay.
All right, so here's a little sample of the number 1 and number 2. This isn't all of it. The customer took most of it back, and he was going to get some assays on it. But all this stuff up in here is all galena. It's the kind of, I don't know if you can tell on the camera, but it's kind of a blue-gray looking sulfide. It's a lead sulfur combination there. But what a lot of times these galena rich veins will have quite a bit of silver in them, where the silver actually gets combined in with the lead and the sulfur, and you can have, you know, hundreds or even thousands of ounces of silver per ton in these lead rich deposits. So we're going to take this and melt it down today, but I wanted to make a quick comment here about the shaker table. You could see on the table how much galena was coming off there, and that's one of the reasons why we like shaker tables so much, is they're a continuous concentrator. So the galena, there was quite a bit of it, and it was just continually coming off the shaker table into the number 1, number 2, and number 3 ports. Whereas like if you have a sluice or a concentrator bowl, they fill up really, really quickly. Their riffles fill up really quickly, and then you would lose a lot of the sulfides. And then also when you pack up your riffles with very dense material, it's a lot harder for the gold to get in there as well. So that's why we like a shaker table. And as you can see, ours worked really pretty well in pulling all the galena out of the gang material that went off into the number 4. But let's get this stuff dried out in the sun a little bit. I'm going to put it on a little cookie sheet, and we'll get it dried out, and then we'll look up our smelting recipe here. We'll talk a little bit about that and get this smelted down and hopefully recover some silver. All right, guys, so I just wanted to show you here real quick. A lot of times I miss some of the details that you guys want to see here on these videos, so I want to make this one pretty comprehensive. I've taken the stuff out of the pan. I've spread it out on this, I don't know, tray, or I think it might be like some sort of planting tray. And you can see the water down here. I like to tip it. This is on a little bit of a hill, but I'll probably block it up and just tip it so it gets more direct sunlight, and then the water can just run down into the bottom of the tray. And so this will dry out really pretty quickly. And then once we get it dried, we'll get some weights on our samples. Okay, here's our nice dried out galena, and usually you can tell it's dried out when there's no clumps in it. All the individual grains are moving around against each other. When it's still wet, it'll form little balls and clumps. And we dry it out for 2 reasons. One is so we can get an accurate weight when we're mixing up our flux, but also I actually, one time early on, I did a smelt with some wet material, and the crucible actually blew up in the furnace. So I like to get it real nice and dry now, just for so I don't have any explosions. So we'll get it put in that pan, and we'll get it inside and get some flux weight up and get this smelting. Okay, I'm going to weigh out for this first little test. I'm going to weigh out 50 grams of the galena. I'm going to add 150 grams of soda ash, and I'm going to add 50 grams of silica. And then we're going to add some iron to help reduce the galena in here to lead metal. The iron's going to take up the sulfur, turn it into iron sulfide. The lead sulfide will turn into lead metal. And the silver will follow the lead to the bottom of the crucible. We're going to use one like this. Down to the bottom of the crucible, the silver and the lead is going to collect down here in the bottom, and then we'll pour it into a cone mold. And the lead button, we will then cupel away, oxidize the lead, which I'll talk about here after we're done smelting this first one. We'll oxidize the lead and end up with our silver button in our cupel. So let me get this mixed up real good. We'll add it to our crucible over here. I'll throw a couple nails in there, maybe an iron rod, and then we'll put it in the furnace. Okay, here's our crucible. I'm going to use just a big, huge iron bar so we can get a lot of surface area for the iron and have a lot of iron in there available to pull off that sulfur from the lead. Here's our little setup. I got a propane tank and a little shop vac here as a blower. They come down into this manifold and mix, blow it into our KO wool furnace. Down the bottom there's some fire bricks where I set my crucibles on. And that's literally just some KO wool with some banding wrapped around it. And the lid I can lift off. This stuff's pretty nasty when you get it heated up, so I always wear a respirator when I'm working around it. Even when it's not hot, I mean, if I started jumbling this around, you can see a bunch of little fibers going into the air. So you want to be careful with this when you're working around it, using it as a furnace. And here's our little cone mold over here. So I'll get it all melted down, and we'll pour it down the bottom, and all of our metal is going to go right down the bottom, and we'll have our slag floating on top. When it cools down, we'll break it off and cupel the lead away and get our silver. Okay, we got our stuff cooled down some, and I put our cone mold in a bucket of water here. And one of the things, especially when you're dealing with lead on the bottom, if you're going to use lead as a collector metal or bismuth, something with a real low melting point, so you want to make really sure that the metal prill or button you have at the bottom of this thing is solid, because there have been a few times where I got real excited and anxious and went to tip this thing over, and the slag's all solid because it has a fairly high melting point, and I dump it over and liquid lead runs out all over the place. So that's why right now, especially with lead, I use water just to make sure the very tip of that cone down at the bottom cools off down below, I don't know, whatever it is, 600 degrees Fahrenheit. And it doesn't take too long in the water because the bottom of the cone has such high surface area for the volume. So I just dip it in here for a minute or so once it's kind of solidified all the way on the top here. And then now we'll get it tipped out and see how much metal we have in the bottom of our cone mold. I started with 50 grams, so we'll get this weighed and see how much lead we have from 50 grams of material. Okay, here's our stuff, and if this worked right, and the flux recipe did its thing, and the iron did its thing, we should turn this over and we'll have a pyramid, and the top of the pyramid will be metal, and right underneath the metal will be slag. And there shouldn't be any mat, which will be a third layer in between. There's a lot of lead at the top there, so let me get a hammer and I'll just kind of peck away at it and see what we got once I got it broken open. All right, well, it's still hot, but there's our slag, our real basic slag. We used a lot of soda ash. It absorbed all the FES sulfide that we made. We reduced all this lead to metal, and there's no mat. So that recipe worked really well. Now, one other thing I may have got in the video, but I'll say it now, when you're using a bunch of soda ash, you want to heat it fairly slowly or it tends to boil over. So I kind of held it at about 850 degrees or 1850 degrees there for a while to let it do its reaction and get the gases off so it didn't boil over. So it takes a little bit longer, and you just got to be patient. But it's always better to get it a good melt with no boiling. So there we go. There's our lead thing. Let me get it banged up. I like to bang it when there's a bunch of slag on it like that. I like to knock it into a little cube or try and get as much slag off of there as I can. So let me get it banged around a little bit, and we'll take a look and then talk about our cupelling process. All right, well, we got our lead button hammered, kind of knocked as much slag off as I could. Now we're going to put it in this cupel and put it in a furnace about 1800 degrees Fahrenheit. And what happens is the lead, which I weighed this actually, by the way, it weighs 35 grams. So we started with 50 grams and ended up with 35 grams of lead, hopefully alloy. Hopefully there's some silver in here. But what this does is when I put it in the furnace at 1800 degrees, the lead melts and then it heats up, and about 1650, I think, the lead oxide that forms on the surface of this thing in the furnace starts to melt, and the lead oxide will run off and be absorbed by this cupel, and that process continues until all the base metals are removed from the lead puddle, and all you're left with is going to be your gold and silver. So what I do is I put a cupel in the furnace and get it nice and warm and hot, so drive out all the moisture, and then I can put my lead block in there. So let's go put this in the furnace, and we'll let it start cupelling and oxidizing the lead away, and then hopefully we'll be left with some silver at the end. Okay, here's our furnace. And our little lead block. Put in there, that'll start melting. There it goes. Now as that gets
heat it up and the surface oxidizes, that lead oxide will start being absorbed by that cupel, and the cupel will turn kind of a dark color, dark gray, dark brown. So we'll check back on that in a couple minutes. Okay, we'll take a look here. There's a little puddle of metal. It's hard to tell in the sun, but it's oxidizing. You can see the little gray ring around the cupel. That's where it's absorbed the oxides. So now that metal will just shrink right up into nothing and leave a little bead of silver, hopefully, in the bottom. All right, it's been a little while. We'll take a look. Yeah, we're down to just barely a little tiny button there. So hopefully it won't get too much smaller. It'll turn to silver. All right, let's check on her again. What I've done is I turned the temperature down to about 1725 because the melting point of silver is at 1768 or something. Let's see what we got. Hopefully it... Oh, that's pretty small. There's a little silver bead though. So here, I'll just pull it out of there right now. I don't know, is that better? A little silver bead.
All right, guys, so we do a little bit of math here. We ended up with a 50-gram sample, which is 1/20,000th of a ton. And out of that 50 grams, we ended up with 0.044 grams of silver. So you got to multiply that by 20,000 to get grams per ton. So 880 grams per ton in the concentrates. That's not how much was in the ore originally. That was in the concentrates. I don't know the exact weight of the material we ran or the weight of the cons, but I'm assuming that, let's say you run a ton and 2% of those ends up being cons. So you multiply the 880 grams of silver per ton of cons by 0.02, and we end up with 17.6 grams of silver per ton, about half an ounce. At 85 cents per gram, there is $15 per ton of silver in that ore. So probably not profitable, but it was a good experiment to show that there's not a lot of silver in there. And even if we're off by a magnitude of 10, let's say, I didn't collect all the silver or we get way more cons or whatever, $150 per ton probably still isn't worth going after. There's probably realistically more value in the lead in this ore than the silver. So just out of curiosity, I wanted to do the calculation for lead now. We ran our 50 grams, got 35 grams of lead. So 35 times 20,000 is 700,000 grams per ton in our concentrates. But going back to our assumption of 2% cons per ton of ore, 700,000 times 0.02 is 14,000 grams of lead per ton of raw ore. That's 14 kilograms. Lead right now is about $2.33 a kilogram, $2.33. That ends up being about $32.62 a ton is the value of the lead. So the lead actually is twice as much of the value as the silver in the ore. And one other thing that I didn't mention earlier is there may be a little bit of gold in here, probably not very much. But even if there's a little bit of gold, you might have $50 a ton or even $100 a ton. You're still in that $100 to $200 a ton range. It might make it profitable at that point, but you're dealing with a lot of lead. You would need a huge amount of volume, and you would have to take it to a mill that could process the volume to get the value at that at those numbers. So this probably isn't great for a sample as far as looking at processing it, but we did our assay, we did our calculations, and now we know. So hopefully you guys can use this information and the techniques I showed you in this video in the future to sample your own ore piles. So thanks again for watching. If you guys have any questions or comments, you can find our contact information in the description below. So thanks again, and we'll see you on the next one.